Okay, folks, here we are, page 174, number 3. We got the lengths of a certain kind of radish, normal distribution. They give us the mean. No, they don't give us the mean. They tell us that 4% of the radishes are longer than 12 centimeters and 32% are longer than 9 centimeters. So let's put some information down here in front of us. We got this normal distribution. We don't know what mean is. We don't know what the variance is. Let's take a look at what this is kind of look like. All right, so basically what they're saying is we've got this length of a radish. We've got a 12 and a 9. All right, those are going to go along the bottom part of our axis. So let's say that's 9 and that's 12. And then we know that, well, above the 12, there's 4%. That's how big that area is going to be. And then above the 9, that's going to be 32%, or if we wanted to look at this one little section, we're going to say it's going to be 28%, because that one little section is 28%. All right, so now let's go ahead and see if we can write this. We've got the probability that the length is greater than 12, and we know that it's 0.04. And the other one, we've got the probability the length is greater than 9, and we know it's going to be 0.32. Now, because we don't know two things, mean or standard deviation, and you can see there's two different ways we can make equations, we're probably solving simultaneously. Now, we do have to change this into a z-value, so we're using the formula 12 minus mu over the standard deviation, and we know that's going to equal, it's the probability, so it's going to equal 0.04. No, yeah, it's going to equal 0.04. So once we've got that, then we can go ahead and we'll think about this. We can't do greater than 12, so we can do less than 12. And we still know the probability. If the one side is 0.04, well, then the other side must be 0.96. So that means if I go ahead and I do this 12 minus mu over standard deviation, well, if I go to the table and find 0.96 and find the numbers that would cause that to happen, so 0.96, I got 0.9599, that's as close as I can get without going over. That's 1.75. And then I go over here, I need to add one more to that last digit. So the number I'm going to have here is 1.751. So 1.751, now all I got to do is multiply, and I'm going to get 12 minus mu is equal to 1.751 standard deviation, okay, theta. Let's do the other one now. Look at the z-value, it's 9 minus mu over theta, and then it's going to equal 0.32. Well, again, we can't do that. So we'll rewrite this as going to be less than. And again, I'm probably writing more than you need to. I just want to make sure that it's clear. But I'm actually going to find less than 9 minus mu. Okay, so it's like 68%. So now I go to the table and I find the value 68% probability, and that's as close as I can get right there. That's 0.46. So then I need to add some more to it, and the closest I can get is 29. So that's going to be 8. So that gives me a value of 0.468. All right, so now all I got to do is multiply that, and I get 9 minus mu is equal to 0.468 theta. Now, I'm probably going to go ahead and multiply this by -1 and stack them up because they're already lined up. If I multiply the whole second equation by -1, well, now you notice that I've got a positive mu and a negative mu. And when I add together, I get rid of the mu's, and now I've got 3 is equal to 1.283 theta. And all I got to do now is divide 3 by 1.283, and I find out that theta is equal to 2.34 with a bunch of other numbers. I'm rounding 3 significant figures. Now the thing is, in order to find the mean, I need to use all the figures. So just in your calculator, save it and multiply it times 0.468. And then you should get the mean. And we're going to round that to 3 significant figures, 0.791 or 7.91. All right. Thanks for watching. Hope that helped.